Hello there everyone, this is Ms. Page, and today we are going to be talking about composition of functions, specifically with respect to exponential functions combined with another function usually given in graph or table form, something like that. So we are looking at composition of functions. So we are learning how to compose functions. And we need to be able to evaluate functions, understand our composition notation, and apply it to functions to find both numerically, which means given as tables of values, or a table of values, graphically and analytically, which would be like f of x equals. All right, so we've talked about this before, but let's briefly refresh. So composition of two functions is when the range of the second function becomes the domain of the first function. So it means that whatever our second function is defined as, we substitute it into the first function for its domain variable, which is its x's. So like over here, this is shown, this would be the range of g of x. And so what we do is we take that g of x expression that represents its range, 2x plus 5, and it gets substituted into the x variable positions for f of x. And so this becomes f of 2x plus 5, which would become 2x plus 5 quantity squared plus 2. And then usually we would, in a situation like this, simplify that, do our algebra, multiply it out, combine like terms, stuff like that. But that starting place, that basic plugging the second function into the first function where its x's are, that's how we always begin. All right, so here for these problems, it says the table gives values of g of x for selected values of x. The function f is given by f of x equals 2 to the power of x plus x. So this is where it connects with what we've been studying in this unit. This is an exponential function. And the table is our values of g of x. Okay, so here we want to find the following. So f of g of 5. So remember that what we do first is what's inside the parentheses. So the first thing I would do is find what g of 5 is. And because the 5 is inside these parentheses, I have to understand that would be my x value. So I go over to the table and I find where I have an x value of 5, because this is my g function. And I get the input-output pair of 5, negative 1. So that tells me g of 5 is equal to negative 1. So now what I can do is replace g of 5 with its output value of negative 1. And so now this becomes f of negative 1. And now I'm going to take and evaluate my f function, this exponential function, for an x value of negative 1. So this gives me now 2 to the negative first power plus a negative 1. So I'm replacing each of those x's with negative 1. Then we use exponent properties with negative exponents. So we have to know, okay, 2 to the negative first power would be 1 over 2 to the first power, which is just 1/2. And so basically what we have here is 1/2 plus negative 1. We need to combine these. There are a couple of ways you could go about it. Some of you can probably just do that intuitively in your head and go, okay, well, if I have a negative 1 and I add 1/2 to it, that's going to be negative 1/2. But you can also do it with a common denominator, which would be 2. This would be negative 1 over 1, multiply top and bottom by 2, and that gives us 1/2 plus negative 2 over 2, which gives us negative 1 over 2. So whatever works for you, because these would be no calculator problems in, I would expect, all situations. Okay? All right, let's take a look at f of g of 3. So again, the first thing that I would do would be what's inside those parentheses. I find my g of 3. So again, I need to go to my table, that's my g function, and find where I have an input or x value of 3. And that is here. And so my output that corresponds to is 2. So that tells me g of 3 is 2. So now what that allows me to do is substitute or replace g of 3 with its output value. So f of g of 3 now becomes f of 2. And now I would evaluate f of 2. So this now becomes 2 squared plus 2, which is 4 plus 2, which is 6. All right, we're going to use the third one here as a practice problem. So once you pause the video and try f of g of 2, please. All right, so welcome back. And so let's take a look and see if you got it. So the first thing we would do would be to figure out what g of 2 is. So we go to our table of values for g. There's our input of 2, which output would be -4. So now in f of g of 2, I can replace g of 2 with -4, which now gives me f of -4. And now we evaluate f of -4. So let's see how we did with this negative exponent. So we have 2 to the -4th power plus -4. All right, so here 2 to the -4th power would be 1 over 2 to the 4th power, which is 1/16. So we're looking at 1/16 plus -4. And so again, you might be able to do this intuitively. It would be like 4 minus 1/16, but it would be negative because the 4 is larger than 1/16. And so that would be a -3 and 15/16. But if in any situation you're not sure, common denominator would be best. So this would, our common denominator would be 16. So we have 1/16 plus -4 over 1. We'd multiply top and bottom here by 16. And this would now be 1/16 plus -64 over 16. And that would be -63 over 16. This would be an acceptable answer, and it is equivalent to -3 and 15/16. If we change the -3 and 15/16 to its improper form, remember, we do the 16 times the 3, which is 48, and then add the 48 and the 15, which would give us 63, and that would be the negative value then. It would give us the -63 over the denominator of 16. So they're both acceptable forms of the answer. All right, let's take a look at what's next. So in this, our table of values is our function f of x, and the table gives values of f of x for selected values of x. The function g is given by g of x equals 2 to the -x power minus 3x, and the function h is given by h of x equals the composition g of f of x. All right, so the first thing that is best to do for h of -1 is to rewrite it in its composition form. So this would become g of f of -1. So now it's pretty much like the notation we were working with at first. So the first thing that we would do would be to figure out what is f of -1. And f of -1 comes from our table because that is our f function. And we find our input value of -1, and it gives us an output value of -2. So now we can replace f of -1 with what it's equal to, which is -2. So this now becomes g of -2. And that now is the second thing we do. So now we take this x and plug it into the x's in our g of x function. So this becomes 2 to the power of, and remember, -x really means -1 times x, so it's like -1 times the x value of -2. Or you could look at it as the opposite of the x value, going to be +2 in a minute, -3 times our x of -2. So now we get 2 to the power of 2, and minus 3 times negative 2 would be like a negative 3 times a negative 2, which is plus 6. And now this gives us 4 plus 6, which gives us a value of 10. All right, let's look at the next one. So h of 2. So again, best thing to do first is to rewrite it in its composition notation. So this becomes g of f of 2. So the first thing we're going to do is we are going to find f of 2. And so f of 2, f of x function is from our table. So over here we have f of 2, and our output is 1. So f of 2 is equal to 1. So now that allows us to replace the f of 2 here with its output of 1. So this now becomes g of 1. And that now is the second thing we do. So g of 1, using our g of x, we get 2 to the power of basically negative 1 times 1, but you might have just looked at that as going to become negative 1, which is perfectly fine, minus 3 times 1. So now we have 2 to that negative first power, minus 3. 2 to the negative first power is 1/2. We have 1/2 minus 3. We do want to be a little bit careful here, I would say, because we want to think of this as 1/2 plus negative 3. So we could do this intuitively. This would be like 3 minus 1/2, but our answer would be negative, which would give us negative 2.5. Or we could get that common denominator of 2. And so we'd have a negative 3's over 1, multiply top and bottom by 2. So we now have 1/2 plus negative 6 over 2, and that would give us negative 5 over 2, which is equivalent to negative 2.5. So either one would be fine. If it's a multiple choice question, you might have to change the form because it might be in a mixed number form. More than likely it would be in the improper fraction form, just so you know, but it's doable either way. All right, let's have you guys pause and try the third one as a practice. Start up again when you're ready to check. All right, let's take a look at h of 1, see how we did. So first off, our h of 1 becomes g of f of 1. And so we'd find our f of 1 first. So looking at our table for f, and here's where we have that input of 1. So the output that corresponds is 0. So f of 1 equals 0. So now that allows us to replace f of 1 with its output here of 0, changing this to now g of 0. So now we plug in 0 to our g function. So we get 2 to the power of negative 1 times 0 minus 3 times 0. Anything times 0 is 0, so this becomes 2 to the power of 0 minus just 0. And we know that anything with an exponent of 0, the whole power equals 1. So this is 1 minus 0, which becomes 1. All right, let's see what is next. Okay, so these couple problems that we're going to look at here are a little different from the composition problems we've looked at so far. And they involve understanding that a composition can create a transformation of the original graph. So here we have the function f, which is defined for the domain from negative 1 to 6 as shown in the graph. So this is our graph of f. And our function g is given by g of x equals x plus 2. The question is here, which of the following, so which of these four graphs, is the graph of y equals this composition f of g of x? So we don't really need to, we have a graph for f, and this is fine for these types of problems. It works the same way. So in this composition, we are allowed to replace, let's start with our y equals f of g of x. So we are allowed to replace our g of x here with what it's equal to in definition form, which is x plus 2. And this now gives us f of x plus 2. This right here, remember we're comparing this to the graph of f. So how does this change the graph of f? And this is changing our x values with a plus 2. So this goes to, you know, like if you're starting with your graph and this right now is telling us this x plus 2, this is like our x minus h structure. So we take the opposite of this plus 2 to give us our h value, and that h would be negative 2. And that parameter there of negative 2 tells us that we have a translation to the left 2 units. So the graph that goes with this composition is actually equivalent to the graph of f moving left 2 units. So I'm looking at, all right, this point would have to move here, and this point would have to move there. And then I have this curve between them. So that's what I'm looking for. So where do I have this point, negative 3, 0, which I have negative 3, 0 here. And where do I have this point, 4, 8? There's my 4, 8. And so A is technically the composition, g of, or f rather, of g of x. All right, let's take a look at this one. So we're going to do this one as a practice problem. So go ahead and pause and give it a try using that same procedure, interpreting the transformation that's happening. Choose your graph, come back when you're ready to check. Okay, let's take a look. So we've got our function f that is defined on the interval or for the domain from negative 5 to 2. Here's our graph of f again. And then we have our function g, which is given by g of x equals 2x. And we want to know which of the following is the graph of y equals the composition of the two, f of g of x. So I'd start with my given composition function, y equals f of g of x. And now I'm going to replace the g of x with what it's defined as, which is 2x. And so now this becomes f of 2x. Then I need to interpret what my parameter of 2 means. So remember, this would be what we often call the b parameters. Remember, all of these two inside parameters, both h and b, they have to change before we can interpret them. So remember, this we want to change to its reciprocal. And the reciprocal of 2 would be 1 over 2, or 1/2. And this is our factor for a horizontal dilation. And that's our factor. So this is important for helping us to understand what math is going on in this one. And so here, with the horizontal dilation, remember each of the x's, and for all of the points, or in general in a function, they are multiplied by that horizontal dilation factor. So what's happening here, let's take these two endpoints. So that is a negative 5, 1, and this one is a 2, negative 3. So each of those x's is going to be multiplied by your factor, or the factor of 1/2. So we take 2 times 1/2, and 1/2 times a 2 is 1. So that gives us the point 1, negative 3. And we take the negative 5 times a half, which would be negative 5 halves, which is negative 2.5, comma 1. So we're basically looking for the graph that has these two endpoints now, negative 2.5, comma 1, and we find that actually here, and 1, comma negative 3, which we find there. So it makes C the correct answer. If you thought it was A, you are forgetting to do the reciprocal part. So A is kind of the big trap answer because it creates a horizontal dilation that's a stretch rather than one that's a compression. And so it's forgetting to do that reciprocal. All right, short and sweet, I think. That is all there is to this lesson. And so, time to start the assignment. Bye now.